Thank you, thank you. So, hello once more. This time it will be my own talk called Foreman Meets Ansible. And I promise there will be a lot more Ansible than in the last one. Let's take a look at, what's ahead of us. We'll take a look at what Foreman Ansible is. We'll introduce it a bit. We'll take a look how to bring your own hosts into Foreman, which might come in handy. Then we will explore the more remote execution-like way of using Ansible from Foreman. And as a counterpart to that, we will also take a look how we can use Ansible from Foreman to do configuration management in the more traditional sense. It will be kind of similar to what Puppet does, or Chef or Salt, or anything. So without any further ado, let's get to it. Foreman Ansible is, as the name suggests, plug-in to Foreman, which allows running Ansible from Foreman. And it is implemented as a remote execution provider. That's the current state. Originally, it started as its own thing, own plugin, without being a remote execution provider. And later we found out that it does many things in a really similar way to how remote execution does them. So we just converted to reuse some parts of remote execution, and it got some new features from this move as well. In Foreman, Foreman needs to know about your machines to be able to manage them. That's the base. If you're using Foreman to provision machines, you don't have this problem, because each time Foreman provisions the machine, it knows about it, right? It just created the machine, so it must know about it. But what if you have your own machines that you can't just reprovision? That would be one way, right? You take the machines, let them be reprovisioned through Foreman, and suddenly Foreman knows about the machines. But what if you can't do this? There's a nice little trick you can do, and that is leveraging the callback Ansible has. Ansible actually has Foreman callback, which reports facts to Foreman. So we can leverage this, because Foreman, when Foreman receives facts, and there's no host matching those facts, it creates it. And we can use this to bring our own hosts into Foreman. So the process has basically 4 or 5 steps. First is that we have to put all our hosts to our inventory. Then we can create a playbook with basically any tasks. Maybe there don't even have to be any tasks. I haven't checked, but it may still work. Next, you need to enable and configure the Foreman callback, which, if you have a production setup of Foreman, is done for you. You just need to change your current user to the Foreman proxy user, which has all the things configured, and you can use that. And then you just run the playbook. Shall we try it? Here you can see my Foreman. Currently, there's only the promoted mosquito, and that's it. Is that readable? Awesome, thanks. So in my inventory, I have 3 other hosts, and this is a development machine. I don't have DNS set up properly, so I'm just using IP addresses as Ansible hosts. But if your environment is set up correctly, you shouldn't have to specify the additional information. You can, it doesn't hurt, but you shouldn't have to. Here I enabled the Ansible callback. It's the second line, the callback whitelist. And because my development instance doesn't use HTTPS, I had to disable certificate validation. That's 0, the last line. And for some reason, the callback still tries to read the certificates, even if you disable the validation. So I just created an empty file and used that as the certificate. The callback reads that and never uses it. So it's kind of hacky, but it works. Again, in production, this is set up for you. You don't have to touch this. And finally, the playbook is just take all hosts and ping them. By default, it also gathers facts, which is what triggers the creation of hosts in Foreman. Now, if I run it, just like this, the inventory, the playbook. OK, SSL verification is disabled. I know about this. Gathering facts goes on. Ping goes on. And if I now look into Foreman, there should be 4 hosts instead of just 1. And there they are. And we can see that one is CentOS, the other one is Ubuntu. The promoted Mosquito was there before, and the last one is Fedora 29. So this is, for me, the simplest way how you can get your own hosts into Foreman and start doing something with them. Now that we have some hosts, we can actually run Ansible from Foreman against them. The most simple use case is just we can select one of them or any number of them and go into schedule remote job. We select the Ansible commands and run command. What it does is that it takes a single input, which is a command, and it renders a template, which is, when rendered, is a playbook. And the playbook says, take all hosts, there's a single task, and the task just executes the shell module with the input you provide here. And that's the rawest form of you can do. It's kind of stupid. Because Ansible is much more powerful, and using it just for remote shell scripts over SSH doesn't add any value over just using remote execution and running shell scripts over SSH. So let's skip this one. You can do it if you want, but why? Next part is what I call playbooks on steroids. And I kind of started this. If you take a look at the job templates, they are ERB templates. ERB stands for embedded Ruby or something like that. And you have the full power of the Ruby programming language in your templates. And that gives an insane amount of power. You can do all sorts of crazy things. I know you can do loops and whatnot with the loop construct in Ansible. But coming from basically anything, if it's Puppet or Salt, Chef, anything, having just the real programming language at your fingertips feels just more powerful. I don't know, maybe that's just me. If we take, for example, take a look at this template, for example, we can see that the template is being rendered for a host. And we take a look at all the roles assigned to that host in Foreman. And if there are any, we render them as a list. And this is a really simple example, but you get the general idea. You can do anything. In the templates, you have access to all the things you should be used from using Foreman. So the sky's the limit. You can do almost anything in there. Next short story I call The Master and the Apprentice. Let's consider a use case that you are managing a fleet of machines, you are using Foreman and Ansible, and you get a new guy on the team, and he's there for the first day, and you don't really trust him, and you don't want to let him break production on his first day there, right? So what you can do is you can create a template, and then you can say, this user, this new guy, can execute this template on a given list of hosts. So you limit on which hosts he can run things, you limit what he can do, and if you put in the inputs in the template correctly, he can kind of parameterize what is being done, but he can't make too big changes. And that can be useful at times. Last section in this section is a bit of an under the hood look. I'll take all my hosts, apart from the Mosquito one, and run something, anything. Okay. Just list the content of the root directory. What happens? In Foreman, a job invocation gets created. This is the job, the thing you're running. And it has one task. It tracks the execution of the entire job. And this task is composed of smaller subtasks. And there is one subtask for each of the hosts in the job. So running this will create 4 tasks on the Foreman server. And each of the per host tasks will delegate its own execution to a smart proxy. So each of the per host tasks will call over to the smart proxy, and then there, tasks are created to track the actual progress of the execution. Each of these tasks on the smart proxy runs one single Ansible playbook process for that one single host. This also kind of explains why in all the templates we have the hosts colon all stanza. Because there is, sorry, not this one. There is always exactly one host in a play. And yes, we could render the hosts to the current FQDN of the host that it is being run on. But we just put there all, and it always matches the one and only host that is there. There were several problems with this approach, mostly related to scale. And the first one was that if you started a job that ran on 1,000 hosts, it would do 1,000 post requests to the smart proxy, as each of the per host tasks was doing its own. That's not that bad. There are worse things. The worst thing was that all these requests came in at roughly the same time, and the smart proxy triggered 1,000, 10,000, the number of Ansible playbook processes. I don't know if any of you ever tried to run even 100 Ansible playbook processes at once. When I tried with, I think it was 1,000, it generated load of 200 on my machine, on my 4-core machine. And I just gave up and had to, hard power off and start over. So, we reworked that a bit. one more thing to add. It wasn't all bad. It gave us power to cancel jobs, to cancel executions of a job on a specific machine. So for example, when you specify which host to run on and you just put a wildcard in there, and then you trigger the job, and when it's running, you notice that there's a host it shouldn't run on, you could go in and cancel it just for that one host and let it run on the others. We could do this because there was a process per host. We could kill that one process for that one host. We reworked it a bit. What happens now is that on Foreman's side, almost everything stays the same. There's still the parent task and the subtasks, but the subtasks don't call out on their own. We introduced a concept of batches, and once the batch is filled, there is the amount of tasks, all of these get aggregated into one big request, and it gets sent over to the smart proxy. That saves us the 1,000 request problem, from the 1,000 request problem. However, we are still left with the 1,000 Ansible playbook processes. We worked on that too, and then Ansible Runner came out, and we thought, why not do two things at once? And as part of this, we reworked the integration to be able to use Ansible Runner on the smart proxy, and also to run one single Ansible Runner process for the entire batch. So the default batch size is 100, if I recall correctly. So now, instead of running 1,000 Ansible playbook processes to run a job on 1,000 hosts, you run just 10 Ansible runners. And the load goes down significantly, but we lose the possibility to cancel the job for a single host. We can't do that anymore. There's no way how we could tell the runner, hey, stop it for that machine. So it's a trade-off, but in general, I think it's worth it. And the plan is, currently we support both implementations. You can go into Administer and Settings, and here in the Ansible tab, you can choose if you want to use Ansible Playbook or Ansible Runner. Just a heads up, the changes are already in master. They should be packaged in NETWAYS, but they are not in a stable release yet. So if you install 122 and don't see this option there, that's why. Now let's change this to Ansible Runner and run the job again. And we should see no difference, hopefully. Another drawback of this is because we always wait for the batch together, that the delay between first results start coming in is a bit higher. Because, in the old way, the first task got planned, it delegated to the smart proxy, and if it ran for, I don't know, a second or two, the result got back really quickly. But if you're in Foreman planning a job for 50,000 hosts, and you always have to wait for the batch to gather to be able to send it over to the proxy, then of course the processing there's a bit higher latency, let's say. And yes, here we can see that even though we used Ansible Runner, we can still get the per host output. It looks almost exactly the same. And from now on, I'm going to be using Ansible Runner for the rest of the demo. Let's take a look. This is the tasking engine console on the Smart Proxy. And if you go into the details, you can see that in what? Okay, sorry. Yes, here in the output, we can see that there was a batch action. This is the old way. And it had 3 children, and each of these ran a single Ansible playbook process, and that's how it was done. In the new way, there's a bit more of those. There's still the single parent action. Then there are 3 output collectors, and those are actions which actually don't do anything themselves and just sit there and receive the output, the outputs for that particular host they're tracking. Then we have, okay, batch runner action, that's actually above them, and a single runner batch action, which is the one which runs the Ansible Runner. I'm sorry about the terminology. Everything is named kind of similarly. And it sometimes takes a bit for all the things to settle in. Anyway, this one actually runs the Ansible Runner and just sends updates to the other actions which can collect the outputs and so on. Okay, let's move to the other part. That's the configuration management like. You have already heard something about roles and variables already today, so I'm going to skip those. Yes, you also saw how to assign roles to hosts. So one thing that is, when you're using Puppet, the agent checks in every half an hour, I think, by default. And in Foreman, you would see a marker that a host didn't check if it didn't, and it would be marked as out of sync. So you could, see if your hosts are actively checking in or if there's something wrong. This kind of applies to Ansible as well. And as you can see, the promoted mosquito as orange icon, which says configuration out of sync. Because last application of roles on that host was about an hour ago, and I have set the expiration interval to 10 minutes. So if that time goes without the host checking in Ansible's case, without us running the roles against the host, it will turn orange. Luckily, there's a way how we can get a pseudo Puppet-like behavior. And that is, we can go to all hosts. We can select them all. We can do a schedule remote job. Here we can select, where is it? Ansible Playbook and Ansible Roles. This is the template we just takes all the roles that are assigned to the host and applies them. And we can use this neat feature from remote execution and set up recurring execution. So Foreman will initiate an application of roles against we can change this to name squiggly line and star to match all the hosts in Foreman. And we can say that we want to, I don't know, run it every hour. And if we submit this, every hour there will be a job created which applies the roles to all the hosts Foreman knows about. And therefore, this way it ensures compliance. The only thing that remains is to go into Administrator and Settings and change the out of sync interval to a value that is a bit higher than the interval set in the job. So we want to avoid the situation where the job is triggered and it still runs, but because there's a lot of hosts, it takes time for the host to actually check in. So I would put there something a little higher. If I was running the job hourly, I would give it, I don't know, 70 minutes, let's say. The only issue with this is that if you have a lot of hosts, it will trigger one single huge job every hour. And you may want to kind of micromanage things and somehow split your hosts into host groups or somehow manage that the executions are distributed over time. And it doesn't happen that every hour there is a huge spike in load because you're trying to apply roles to 100,000 hosts. And just to show you that I'm not making this up and applying Ansible roles actually fixes the status, we can see the promoted mosquito is out of sync. And I deploy Ansible roles on it. And if we wait for a while, I should have prepared some jokes or something. Okay, we can see it's a success. And if we look into all hosts, it should now be green. Yes, all of our hosts are now green. And the last thing are facts. Ansible gathers quite a lot of facts, as do all the others. And we can use Foreman to actually look at them. So for example, if I'm interested in, let's go with the promoted mosquito, it's a favorite. We can take a look at facts of the host. And we can see all these things like the user ID, user GID. They were running as root, so it's not interesting. And they are all containers on the same host, so all the CPU models, memory free and stuff like that, that won't be interesting. That will be the same on all of those. But what can be interesting is Ansible distribution, for example. Yes, we can see that that machine is running CentOS. And what Foreman gives us for free are charts. So it can take a look at all the hosts and all their facts, and it can generate charts from those. So if you want a quick overview, for example, what operating systems am I running on my machines? You could go and check each of these machines, or you can just go here and click View Chart, and you can see that half of my machines are on CentOS, quarter on Fedora, and quarter on Ubuntu. That's really nice. And that's about it. Do you have any questions? Or any suggestions what to do? I can break the machine, so go on. Knock yourself out.
Any questions? So it's the usual. Nobody had questions to Martin, but then he had no chance to have a coffee break afterwards.
I see.
Okay.
Okay, if there are no questions, then thank you very much.
Thank you. Thank you very much.